Hey everybody, my name is Chris and I'm a tutor here at Chegg.com. I mostly do math and a little bit of computer science, and in this video we're going to do an example of an iterated integral, and we're actually going to do it two different ways to show that when we do an iterated integral two different ways, we actually do get the same thing. So here we're going to evaluate the integral from 0 to pi over 4 of the integral from 0 to pi over 2 of cosine of x plus y dx dy, and then after that what we're going to do is swap the integrals and swap the order of integration basically. So then what we're going to have is the same function, cosine of x plus y, but then we're going to integrate dy dx instead of dx dy. And notice that our integrals have also been swapped. So here, for the first one, we're going to integrate 0 to pi over 2 on the inside, and then the outer integral is from 0 to pi over 4. And then it's the other way around. Here, the inner integral has 0 to pi over 4, and the outer one 0 to pi over 2. Okay, so let's go ahead and get started. So what we want to do is work from the inside out. So this integral is going to be equal to the integral from 0 to pi over 4 of... Now, what happens here, if we integrate this with respect to x, remember y is just a constant, so we're just going to treat y as a constant. So think about what would happen if we actually had a specific constant. If we wanted to integrate cosine of, say, x plus 5 dx, then what would that be? Well, that would just be sine of x plus 5, right? We wouldn't really have to make a u substitution. It's not really that complicated. I mean, we could if we wanted to. There's nothing wrong with that. It's just not really necessary because we just have it x plus 5, for example. So instead of 5, though, we have y, but it doesn't matter because we're treating y as a constant. So y can just be regarded as any old constant. And yeah, technically I should have had a plus c over here, but we are doing a definite integral for a specific example, so it's okay. Anyway, when we integrate the cosine of x plus y, we're just going to get the sine of x plus y. And because we integrated with respect to x, then we're going to evaluate from x equals 0 to x equals pi over 2. And we do want to be very careful that we actually specify that this is for the x, so we don't get anything confused. And then we still have our dy over here. Okay, now this is going to be equal to the integral from 0 to pi over 4 of... Now we just evaluate. This is going to be sine of pi over 2 plus y minus sine of 0 plus y, which is just y. Oops. And then we still have all of that dy. All right, now this is just a plain old calculus 1 type integral, so we can just integrate as usual with respect to y. So when we do that, we're going to get... Now here we pretty much have the same kind of thing we had up here, but now we have an actual constant, pi over 2. Okay, so when we integrate this, we're going to get minus cosine of pi over 2 plus y, evaluated from 0 to pi over 4. Now we don't have to specify y equals 0, y equals pi over 4, because y is the only variable left. So while it's not a bad idea and it doesn't hurt to be that thorough, it's not really necessary in this case. Okay, so continuing then, and then when we integrate minus sine of y, that's going to be minus negative cosine of y from 0 to pi over 4. All right, now let me go ahead and come up here, and I'll change color so it's a little bit easier to read. Now we have minus what? So this equals minus cosine of pi over 2 plus pi over 4. And then we're subtracting minus cosine of pi over 2 plus 0, so that's cosine of pi over 2. Right, and then minus means plus, so then we have plus cosine of pi over 4 minus cosine of 0. And these square brackets here aren't really necessary, but just to keep clear everything that's happening, this is what we have now. So this minus sign right here is the same thing as this minus sign here, and then these two minus signs combine to make this plus sign right here. All right, so that's what's happening there. Now let's continue and evaluate. So pi over 2 plus pi over 4, that's 2 times pi over 2 times 2, which is 2 pi over 4. So pi over 2 plus pi over 4 is 2 pi over 4 plus pi over 4, which is 3 pi over 4. All right, So that's going to be 3 pi over 4. Let's go ahead and get rid of all that. And then what's the cosine of 3 pi over 4? Well, that pretty much just comes down to knowing the unit circle. So if we think about the unit circle, the cosine of 3 pi over 4 is going to be negative. So we saw this minus sign out here from here. And then the cosine of 3 pi over 4 is negative root 2 over 2. Right? And then minus the cosine of pi over 2, that's just 0. And then plus the cosine of pi over 4. So the cosine of pi over 4 is root 2 over 2. And the cosine of 0 is 1. All right, now let's go ahead and simplify a little more. So what we have is minus negative root 2 over 2. So that's positive root 2 over 2. And then we have plus root 2 over 2 minus 1. So root 2 over 2 plus root 2 over 2 is 2 root 2 over 2, which is just root 2. And then we're still subtracting this 1 here. All right, so this is the answer we get when we do it this way. Now let's go ahead and evaluate this integral again, swapping the order of integration. Right, and we can do this one a little more quickly because it's more or less going to be pretty similar. So when we integrate this, remember we work from the inside out. So we're going to have the integral from 0 to pi over 2 still. And now we're going to integrate this with respect to y, so we treat x as the constant this time. But the general idea is still exactly the same. So we're just going to end up with sine of x plus y, and then we're evaluating from y equals 0 to y equals pi over 4. Okay, and then we still have our dx over here. Oops. Still have our dx right here. And then this is going to be the integral from 0 to pi over 2 of sine of x plus pi over 4 minus sine of x plus 0, which is just x, close square bracket, and we still have our dx. Now, this is just a plain old calculus 1 type integral with just one variable here. So now let's go ahead and integrate with respect to x, and we're going to get minus cosine of x plus pi over 4 evaluated from x equals 0 to x equals pi over 2. And then if we integrate minus sine, we get minus negative cosine of x, okay? And again, evaluating from 0 to pi over 2. So just like we did on page 1, let's go ahead and come up and change color so it's easier to read. We're going to come up here, and then we're going to get that this equals, so minus, then we have cosine of pi over 2 plus pi over 4 minus cosine of 0 plus pi over 4, which is pi over 4. And that says cosine. Close the square bracket. And then minus minus gives us plus. Then we have cosine of pi over 2 minus cosine of 0. All right, so this minus sign right here, that's this minus sign up here. And then these two minus signs combine to give us this plus sign here. So that's what's going on there. All right, now let's go ahead and simplify this. So cosine of pi over 2 plus pi over 4, that's exactly what we had over here. And we saw that that simplified to negative root 2 over 2. So this, we still have the minus sign out here also. So negative root 2 over 2. And then, whoops, minus cosine of pi over 4. So cosine of pi over 4 we know is root 2 over 2. So this is going to be minus root 2 over 2. And then plus cosine of pi over 2 is 0. And cosine of 0 is 1. So this is minus 1. All right. And then what we have when we simplify a little more is, well, we have a minus sign out here. So this is minus. And then what's happening in here? Minus root 2 over 2. Minus root 2 over 2. That becomes minus 2 root 2 over 2. These twos cancel, and we just end up with minus root 2. Okay? So that's what's happening in there. So we have minus root 2. And then plus 0 minus 1 just means minus 1. Equal sign over there. And then finally, negative root 2 becomes positive root 2. And then we still have our minus 1 here. And notice that we end up with exactly the same answer that we had the first way we did it. Okay, so this has been an example of doing an iterated integral 2 different ways to verify that we actually do get the same thing both ways. I hope you found this video helpful, and thank you for watching.